Let's take a closer look at the inverse trig functions and their restrictions. As we have already seen, y equals sine of x. If we think about its graph, here's the original graph. Okay. And we know that this particular function does not pass the horizontal line test, right? We have seen that already, right? We see that there that we get intersections there, and therefore we need to restrict the domain. And we discussed already how to restrict the domain. The only way it's going to pass the horizontal line test is if we stop that horizontal line such that it only passes the horizontal line one time, right here. And also, as you keep going, you'll pass the horizontal line right here. And so we see that the restrictions occur just within this space here, and we get that value from negative pi over 2 to pi over 2. So remember that we need to restrict the domain from negative pi over 2 to pi over 2 inclusive. And if you take a look at how, so that's the domain. If you take a look at the range, notice how you're going from a low value of negative 1 to a high value of positive 1. So the range would go from negative 1 to 1. Now in doing so, what we're also going to do is think about the graph of inverse sine. So as we develop a coordinate plane, actually let me draw it over here. As we draw the coordinate plane, remember that whatever used to be x now becomes y, and whatever was y now becomes x. So what used to have the x values at pi over 2 and negative pi over 2 now become the y values. So we're going to see that the y values are at pi over 2 and go to negative pi over 2. Likewise, whatever was the range which used to start at 1 and go down to negative 1 is now going to be seen along the x-axis, right? We're now going to have a 1 and a negative 1, something like that. Okay, and then from here, what we're going to do is remember that that the inverse is really just a reflection across the line y equals x. So if we think about the line y equals x, something like this, right? How whatever is on one side of the line gets reflected over to the other side of the line. Notice here the sine graph, it's on top of that line y equals x, and therefore will get mirrored over onto the bottom portion, which I'm now going to draw. You know, that bottom portion is going to get mirrored more like a curve like this, right? Like this. And so it ends up stopping at that value of 1 comma pi over 2. And then likewise, whatever was on the bottom portion, that curved portion below y equals x, now gets mirrored over to the upper portion of y equals x. And so we're going to see that that curve goes over here. Okay, and so you can see here that the domain and range have also flipped, that now the domain of our graph is going from negative 1 to 1, and the range of our inverse function is going from negative pi over 2 to pi over 2. Okay, so that's when we look at the inverse sine function and its restrictions. Now the inverse sine is a function. Okay, so we've restricted the domain, it's all good. Now let's go ahead and apply the same technique to the cosine function. Okay, so when it comes to cosine of x, let's draw the original cosine function, which, if you recall, kind of looks like this. And we'll do the same thing on the other side. Okay. And what we want to do is, remember, we want to pass the horizontal line test. And how do we pass that horizontal line test? Oh, look, right away we can see that the horizontal line does not pass because you know, we get those 2 intersection points or even 3 intersection points along the same line. So something's not working here. Remember, when we start off with measuring angle measures, we always start with the initial ray, which is going to be at the 0 location. So we want to start at 0 and make our way along. So how can we make sure we pass the horizontal line if we start at 0? Well, if you go left and right, unlike the sine function, it's not going to pass the horizontal line test immediately, because you'll see that right away it doesn't pass the horizontal line test at the pretty much near the top. So we need to make sure that it passes the horizontal line test, and the only way we can do that is by restricting the domain, so we just don't go in one territory at all. Okay, so we're just going to not go in this territory at all and just go in the positive direction and work our way counterclockwise so we can get a positive angle measurement. So in doing so, now we pass the horizontal line test by only intersecting our function one time, and just keep thinking to yourself, when is the location where I'm not going to pass the horizontal line test, where I start intersecting that line 2 times? And hopefully what you're seeing here is that it's going to occur right at this location here. Right now it does not pass the horizontal line test, so we have to stop it at the minimum value right there. So we're going to start it at 0 and make our way over to, that's the value of pi, right? Because if a full revolution would give us a value of 2 pi there. So we need to stop it at pi. So what we're doing here is we are restricting the cosine function to a domain from 0 to pi inclusive. We can include the value of 0. We can include the value of pi. We still pass the horizontal line test at those locations. If we take a look at the range of those values, you'll see that you go from a high of a value of 1 to a low of a value of -1. So our range is going from -1 to 1, inclusive again. Okay. Now if we look at the inverse cosine function, remember that this is just a reflection across the line y equals x. So if we were to actually draw our line y equals x here, just imagine that we have a line y equals x like this, then whatever is on one side of that line is going to get mirrored over to the other side. So just keep in mind what we're going to do when we reflect it. Okay. So as we graph this, let's think about some points that we definitely have. Remember that we definitely have this point here. Currently, it's at the point of pi -1. And so that's going to get mirrored over to the point -1 pi. Remember that x's and y's switch. So -1 and pi will, maybe it's going to be somewhere around here. So -1 pi will get mirrored over here. So that value of pi -1 gets mirrored over to the point of -1 pi, which is located in quadrant 2 now. Remember that this point basically just got reflected across the line y equals x. Okay? As we take a look at another point, we also have the point at 0 and 1, right? So that point 0, 1 now gets mirrored over to the other side at 1, 0. So 1, 0 is going to be right here. Here's 1. And that's the point 1, 0. Okay, so this point, again, just gets reflected across that line y equals x and gets placed over there. Everything else also gets reflected. So just imagine everything else that got reflected here. One point in particular that I want to pay close attention to here is maybe where that x-intercept is, right here. We can see where that intercept is. In terms of your cosine values, we know that cosine gives you that value of 0 when you actually go a quarter circle away around, and that value is a value of pi over 2. So we know that the angle measurement is pi over 2, 0. This point is pi over 2, 0. So if that gets reflected over, then that point pi over 2, 0 is now reflected to 0, pi over 2, which is going to be right here. 0, pi over 2. And then from there, we can also just kind of see how that those curves are formed. The curve kind of comes up like this. Oops, that's a bad curve. Here we go. Like that. And then it starts to make its way up like that. There we go. Okay, so this is the cosine inverse function. And as you can see here, remember that the domain and range of the original function gets swapped. So now for the cosine function, your domain is going to be from -1 to 1, and your range is now going to be from 0 to pi. Like that. Okay, and so as we are doing this, keep in mind what these functions look like. You do need to be aware of what inverse sine function looks like, what inverse cosine function looks like, and lastly, we're going to do the inverse tangent function as well. Okay. One thing to pay special attention to as well, sometimes you want to think about how the inverse functions restrictions, you can think about it on the unit circle as well, how inverse sine, its restrictions go from -pi over 2 to pi over 2. You only want to include things that are in quadrant 1 and quadrant 4. And for inverse cosine functions, you want to think about it how the restrictions are only going from 0 to pi. So these are the restrictions for inverse cosine. Okay, so I'm just kind of darkening these because these are going to be really helpful pictures to determine certain values based on inverse restrictions. Okay, now let's do the last one, inverse tangent. So as we look at the tangent function, I'm keeping the same color. As we look at the tangent function, oops, that's not a very vertical line, but I think you'll get the idea here. So we keep in mind that inverse tangent has asymptotes at the values of pi over 2, negative pi over 2, and it keeps on going, right? Every value of pi, okay? So what we'll see here is that with the tangent function, it looks like this, you can definitely see right away that this function is not going to pass the horizontal line test, right? So in order to not pass the horizontal line test, we need to restrict the domain. Remember, when we start at the value of 0, how do we restrict the domain? Well, we definitely want to make sure we include these points along the horizontal line test because it's closest to 0. So you'll definitely see that these extra tangent curves should not play a role in our inverse trig function. We really want to keep it to 0. And so if you think about the unit circle, if we start at 0 and work your way, you're going to get to pi over 2 here. That's our restriction here. And then you also want to work your way backwards to get to this spot of the tangent. And so again, your restriction here is just going to be between pi over 2 and negative pi over 2. Now, how is this different from sine? Now, keep in mind that for the tangent function, you don't actually have values at pi over 2 and negative pi over 2 because of those asymptotes. So the difference here is that even though you're going from negative pi over 2 to pi over 2, these are going to be non-inclusive restrictions here. Okay, so the domain goes from negative pi over 2 to pi over 2, non-inclusive. And the range, you'll see, goes up and up and up, all the way up and all the way down. So it's going from negative infinity to infinity. So for the inverse tangent function, what's that going to look like? Well, if the point goes from pi over 2 infinity, then we're going to now have the point at infinity pi over 2. So now instead of having the vertical asymptotes, we now have vertical asymptotes at pi over 2 and also at negative pi over 2. And very similar to how you can reflect this across the line y equals x, you'll get your curve almost looking like an S shape, like this. Okay, so you'll see that whatever was occurring way up here at pi over 2 comma infinity is now occurring over here at infinity comma pi over 2. Okay, and likewise on the other end of the spectrum as well. So as we can see here, the domain restriction for the inverse tangent function is going from negative infinity to infinity, and the range is going from negative pi over 2 to pi over 2, non-inclusive. Okay, I do want you to pause the video, rewind if necessary, really get the understanding of what's going on here with the inverse trig restrictions. They are going to be playing a very important role as we move through the trig unit, so be very careful with the inverse trig restrictions. One last note I wanted to mention in this video, I did mention to you already the two pictures that I would like for you to just kind of visualize in your head in terms of the restrictions. If you think about the tangent functions, inverse tangent functions restrictions, again, we got the same idea that we want to restrict it from negative pi over 2 to pi over 2, but remember that this one is going to be non-inclusive, so don't include the values that are at the very ends. Okay, so these are the three pictures that I would like for you just to burn into your head. Just remember those pictures, and those are the restriction values of your inverse trig functions.